All right, problem 19. We've got to do a proof. So we're trying to prove that triangle ABD or ADB is congruent to triangle EDB. Okay? And they've given us a few things. Okay? They've given us a few things. They've told us that B is the midpoint to AE. So what does that tell me? So if we're going to set up a proof, the first thing I can do is set up number 1, draw my line for the other side of the column proof, right? And let's put that down a little bit. And so we always start with something given. So right here, I have B is the midpoint to AE, right? And so that's just given. And that's always where we kind of start. But what does that tell me? What does it tell me? Perfect, Kiko. What does it tell me when we have a midpoint, right? What does it tell me when B is the middle point to this? Does anyone know? It's a bisector. Yeah. That means it's cut in half. Right? And if it's cut in half, that means these two are congruent. Okay? So anytime anything's cut in half, right? If I take these two pins, I cut them in half, and they're going to be congruent to each other, right? It just makes sense. So number 2 is exactly that. We're going to go with AB is congruent to BE. Right? And then, so if we say because in here, remember we were talking about this last week, anytime we say because, what are we going to use for that? What word do we use for that? Do you remember? Not then. Starts with a D. Huh? So anytime you end up saying, it's because of this, it's because of that, it's because it's the definition. The definition of what? The definition of a midpoint allows me to say that these are equal. That's it. Or that they are congruent. Does that make sense? Okay? And so then we move on to the next one. Can I get anything from that? Now, I can't use just the same as these. That's saying that these are congruent, right? So if I'm going to use this symbol, I need to make sure that that there's 2. It's showing that this is different than this. But it's the same as this, right? So with number 3, we want to look for something else. And we know that there's another given, so we can always go to that. So AD, and go back to black for number 3. ED, it says, is congruent to AD. Okay? So this is congruent to this, and it's given. So that's pretty easy. It was given to us. Alright, so what else do we need? Remember, we're trying to prove they're congruent. Do we remember all the 5 congruent pieces? Because with last period, we went over them all. And over here, if you want to take a look. Okay, so what are some of the congruent pieces? Huh? Or just like, what are our rules? Side, side, side. Kiko, give me a rule. Angle, side, side. But only if it's... Right? But only if it's what? Perpendicular, right? So it has to have hypotenuse and a leg. So angle side side is only going to work, right? Is only going to work if it's perpendicular. Right? Give me another one. Someone. Anyone?
Side angle side.
Side angle side, good. Side, angle, side. And another one? There's 5. What? Angle, side, angle. Good. Angle, angle, side. Alright, so there's our 5. So we know we got to find one of these 5 to prove this, right? And so far we have 2 sides. So it's either this one, or this one. But I don't see a perpendicular yet. We might be able to prove it. So what are we going to try to find? Is there anything else? Is there any sharing going on? BD. Okay. That's a good one. BD is congruent to BD, right? Identity. 4. But if I wanted to, I could have also said BD was congruent to DB, and what would that be called? Reflection. Or reflexive. Sorry. Reflexive. Okay? It's like reflection, but it's reflexive property. Okay? So now we know that these are congruent. So what do we have here? Anything? Yes, why? Side, side, side. Good. So 5 is side, side, side. So we have to rewrite the proof. ADB is congruent to triangle EDB, right? And why? Side, side, side. Okay? So we also have to come up with a flow chart here, though. Okay? The flow chart means that we go from 1 to 2 to 3 to 4 to 5, right? But how do we go from that? Okay? So we start with 1. Now with 1, does that get us to 2? Yeah, it is. From 1, does it get us to 2? Did we get 2 from 1? Guys? Did we get 2 from 1?
Yeah.
50-50 chance. He's right. We did, right? It was a midpoint, and then we found that they were congruent because it's a midpoint, right? So 2 came from 1. Right? Now, did we get 3 from 2? Did we get it from 1? We just got it on its own, right? Its own accord. So it's just out here. 3. Okay? Now, what about 4? How did we get 4? On its own, right? We figured it out because it was its own deal. Okay? So 4 was on its own. And then how did we get 5? From 2, from 3, and from 4. Right? Side, side, side. We had to have a side from number 2. We had to have a side from number 3. And we had to have a side from number 4 in order to get 5. Right? So this is a very complex flow chart. Probably the most complex one that you'll have. Right? Usually it'll be like 1 to 2 to 3, and then you'll have 4 and 5, and then 3 or 5 and 3 go to 6 or something like that. Okay? But this one's a little bit more complex. Did we get it to record this time?